Sorry. I'll get that fixed. Oh, no. Oh, no, it's fine. All right, it is time to get started. Welcome to the TLS working group session. There are two sessions, one today and one on Wednesday. All right, got everything ready to go. This is the new IETF note well. They would like us to linger on this and read this little quote. This is the IETF note well. It's a reminder about the policies and the processes and policies, including about conduct, privacy, and intellectual property rights. You agree to follow and participate in the IETF. Please read it carefully. You're encouraged to read the source documents to which the note well refers. If you have any questions, please talk to the working group chairs, us, or the area directors, Paul. You can scan the QR code to get a link to the documents. All right, there we go. Meeting tips, please make sure to use the on-site meeting tools. It's how we're going to use the queue to make sure people in remote land can also get to talk. And it also makes sure that we get the right sized room. So please make sure to log in there. The next thing is the agenda. Again, we have two. A little bit about the agendas. We get more requests often than we actually have time for. Some of the topics are quite controversial. I think last time we were a little bit rushed, so we've given a little bit extra time for people to try to make sure we can come to consensus on any of the open issues. So we're going to start off with us doing a bit of a monologue about the status. Then we're going to jump into the working group IDs, which hopefully some can go kind of quick. Some might take some discussion. And then we're going to have Rich follow up with some DE, distinguished expert reports. And then on Wednesday, we're going to do DTLS BIS update from Ecker. And then we have two non-working group drafts, which are related to ECH. Any additional bashing? Nope. Okay. I'll pull the slides up. Sorry.
You gotta
I gotta
put up the other deck. All right, we're going to talk briefly about document status. All right. Okay, so we've completed, well, the at least part of the appeals process has completed with these documents, and so the MLChem draft, the complaint was unsuccessful, and the ID is still a working group adopted draft. And in the situation with SLH DSA, the appeal was a success, and the internet draft is not a working group item. That's status there. We have a bunch of documents in flight, quite a few. There are two that are in ISG evaluation that deprecate obsolete key exchange and TLS 13 PKCS1. There's some discussions that are still lingering. We're working on getting those resolved hopefully this week. And we have two documents that are waiting on implementation experience. If anybody has any experience with these, then it'd be good to know, so we can start trying to move them forward. Finally, we've just completed a last call on ECDHE MLChem. We did, during chair review, we found that one of the sections of the document obsoletes the experimental code points that were registered for previously, before the NIST standards were completed. The intent here would be to mark them as D in the registry. Unfortunately, or fortunately, this requires standards action. So we have to figure out what the path forward is here. We basically have two options. One is we can move the current internet draft to standards track. There was a fair amount of discussion during the working group last call on this, so we want to validate this with the working group. Basically here, there are no other changes other than to mark the experimentally registered code points to D, discouraged. The other option is we just pull that section out of the current document that says we're going to obsolete these experimental code points, and we go and create a short document to just obsolete those experimental code points and get that through the working group pretty quickly. There is also the possibility of an IESG action, but the preference here would be to do this through a document rather than trying to go directly to the IESG. So what we'd like to do is take a show of hands here as to what the working group would prefer in the room here. And if anybody has any clarifying questions, now would be a good point to ask. Okay. Is it?
I have a.
So yes, we only get yes and no options? We can't change the yes and no?
I can give it a title. I can give it a title and I can start it.
Okay. All right. Well, then.
I have a question.
Yeah.
Which one is the faster way of going about this? It sounds like option A is the faster one, but I want to confirm that that is the fastest way of dealing with this with the least amount of effort, because I feel like any effort that we waste on this is wasted effort.
Yeah.
So
I think option one is the quickest way if we can come to agreement on.
So
That's the yes. The option two is the no. So option one, yes, means we take the current document and just move it to standards track and make the change to deprecate the experimental code points. No is we create a new document to do just that.
Sorry, so while people are voting, Palo Alto's 80, I think this technically means we need to do another last call, right? If we change the track.
We would have to.
Maybe a 1 week last call, but just a quick last
Yes.
call.
Yeah,
and it
we
also
would
confirms it on the
confirm.
list anyway.
Yeah, we would confirm it on the list and we call it a last call, I guess is. Yeah.
how much longer do you want to go?
I think we're probably good. No, it keeps climbing though.
I mean, there's
All right,
100
let's call it good. We have a pretty strong consensus to do number one, so we'll take that to the list. Okay.
All right, cool. We thought that was going to take a lot longer. All right, cool.
All right.
Uh,
Who's up
I
next?
believe it's Steven. One second. There you go.
There you go. Next slide.
You-
Oh, nice.
there you go.
So this is probably the only slide we need. So we published draft 10 from comments we had previously, and Watson gave us some good comments. We think it's ready for working group last call again. I think the plan was to kind of wait, do a working group last call. And if that's all good, then hang around until we get somebody else to implement it, which is fine. There's no open issues. We did move the Git repo, so I'll spin out a draft 11 that fixes the link to the old Git repo. And then that's all. I don't think there's nothing to talk about.
I mean, I think that I think Watson beat me to the working group last call, and then he sent comments before that. So that was it. So I think basically what you're saying is you'll spin a new version. When we see a new version, we'll working group last call it.
Great.
And that's
Yep.
that would be the plan. Okay.
And I'll do that in the next 5 or 10 minutes.
Well, that's it. There's 3 more slides.
I could redo this batch thing.
Okay. Now I believe it's Yaroslav. Update. Control. Slides. Give 1 second. There you go.
All right. Hello, everyone. I'm presenting on behalf of co-authors of Extended Key Update, our latest iteration of the draft. We have published 07 recently, but we only published 06 before the cutoff, so this presentation will be on updates that we've done in 06. Again, quick reminder, what is Extended Key Update? In regular TLS 1.3 key update, you get new keys derived from the same material, so it solves confidentiality limit of EAD, but doesn't give you post-compromise security. Idea of extended key update that you do a fresh Diffie-Hellman key exchange or whatever TLS group you negotiated, and so your blast radius of potential compromise is reduced. Few updates that we've done recently. So we tightened up terminology. So converged to post-compromise security. There were lots of meta kind of discussions about what is perfect forward secrecy or forward secrecy or backward secrecy. So right now the term, the least controversial term seems to be post-compromise security. And there are some references that we've added to hopefully that is acceptable for everyone. There is some more terminology that we need to tighten up in the document that we will be working on. The most significant, I would say, update in this version, previously we were registering 3 code points in TLS message types, and that's too much because it's a single byte and there is very limited number of messages we could have in the future. So we followed Acro's advice and now moved to a single extended key update message with a single byte message subtype. And there are 3 subtypes that we define: key update request, key update response, and new key update that tells that new key is now in operation. We will be asking for IANA registry. Just maybe somebody will want to do something else with extended key update message, some kind of other post handshake thing. So instead of registering a new message type, they would be able to abuse or extend the use of this one. And there are many more bits remaining after 3 bits that we have here. Okay, then another relatively significant change is normal failures. So at some point we decided that allowing both standard key update and extended key update is potential recipe for disaster, because you could have all sorts of wonderful race conditions and clashes. So we suggested, and it was more or less accepted by the working group, that if you negotiate extended key update, you no longer do the regular key update. But that also means that we cannot really fail. So if you agreed to do extended key update, you actually need to do it. You cannot anymore say that, hey, I changed my mind, I don't want to do extended key update anymore. So we completely got rid of error codes. The only response that you have to request for key update is, well, you have to complete the key update. That doesn't mean that you have to do it immediately. If you're too busy doing something else, then potentially you could delay a little bit. And if requesting party got tired of waiting, well, they can terminate the connection. And similarly applies, so there are no more error codes such as retry or I don't want to do key update that we had previously, and that should significantly simplify implementations. Okay, we have added security considerations. There is a little bit more work to be done on the security considerations. So first, scope of key compromise, so what we are protecting against and what security risks obviously are remaining. Post-compromise security, denial of service security considerations. So if you have negotiated an expensive TLS group and you're really low powered, then be careful with extended key update, because potentially you can be DOSed if you're really not careful with doing way too frequently extended key update, and operational guidance. Another thing that we've added that is still work in progress, unfortunately we couldn't finish it in time for 06, is TLS, DTLS state machines. So right now in recent versions they are updated, but still work to be done. I encourage working group to review those state machines and provide feedback. Those state machines are in appendix, so they are informative. But still, the feedback that we've got so far, they are very useful for implementers to understand what is going on and what can possibly go wrong. So next steps for us. Something that we've already done in 07, but as far as this presentation is concerned, it's next steps. Align labels and key naming with TLS 1.3. Another suggestion that we had from Ecker previously, there was no benefit of having separate HKDF labels compared to regular TLS key schedule. So we would be in the newer version, we have exact same labels as in TLS 1.3. More clarification around impact on exporter APIs. So exporter API is challenging when it comes to extended key update, because for some applications you want to keep the same exporter and accept the fact that you could have been compromised. In other applications, you're okay with deriving new exporter after extended key update happened. So implementations may want to have two separate APIs for exporters, one that would be up to date and another that would be original one, but might be outdated now. We will be finishing non-normative state diagrams in appendices, because again, the feedback that we've got is they are helpful for implementers. We've done few prototype implementations. Hannes did one on Embed TLS. I did one prototype on Rust TLS. Seems to be working. We will be obviously doing more, and we are looking for enthusiasts who would be interested in building an implementation and working with us on interop to explore this further. And we're obviously looking for more reviews. We would like to further refine this draft and get it finally on the path to working group last call within foreseeable future. Any questions, suggestions, concerns? Yes, Osama.
Thanks for the updates I provided on the overview. One question I have still outstanding is, how would it be possible for an attacker to compromise the application keys and not the long-term keys? The answer that was given to me was that the long-term key is protected via trusted execution environment. And I'm struggling to see why would you not protect the application keys also in the same trusted execution environment? Like, why would you have the application keys not protected while just the long-term key being protected? I believe that's the whole motivation of this work, right? That
Can you clarify a little bit, what do you mean by long-term keys?
Long-term keys with which you do, so the post-compromise or whatever you are calling is to say the key which is not compromised. So the application, so we're
doing fresh key exchange.
Right.
And deriving new keys for key schedule from that.
Sure, but
meaning that it's previous when compromised, like you had a memory dump, then you can no longer decrypt the session that's in flight.
Right, but why would you? If one can do a memory dump, why can't it extract out the long-term key? That's my question.
Again, I don't quite follow what long-term key you're referring to here.
So the server has an identity with which it is authenticated.
Okay.
And the keys are the ones which
you
are
mean private key of certificate?
Yes, the PKI certificate identity.
Okay, that would be a separate attack surface.
Yeah.
That's not necessarily related to already established session, right? So if we took a memory dump and somehow server private key was also in that memory that got compromised, we did extended key update, even that you possess a private key of the server, that won't allow you to compromise already established session.
But I don't think that. So do you have a realistic example of how one could compromise one but not the other? I'm struggling to see a use case of that.
So
Because
you have
typically
you have a long-standing session,
yeah,
right?
right.
So an attacker managed to get a snapshot of memory
Yeah,
and be able to decrypt data that is being transferred in that memory.
but here
Right?
is my
The
problem.
attacker also now have somehow private key of certificate of that server. Extended key update happen. You still have access to the private key of the server, but you can no longer extract data, clear text data from that long-term session that's already established. And that's what we're trying to solve here.
Okay, maybe you can clarify in the draft, because I still have trouble to follow the kind of use case to have. You assume that one key is compromised but not the other. That doesn't
No,
make.
we're not assuming that.
So you say in the draft that the long-term key is not compromised. That's what Hannah
The
said.
draft doesn't say anything about long-term keys.
Okay, I will see the terminology that it used, but anyway, in the issue it was mentioned that the long-term key is not
Okay,
compromised. And
I
also in
don't
the
believe we're
PR.
talking about certificates or identity in our draft.
Right, when I say I didn't, yes. Sorry.
So I think there's confusion here, Pavard. You've got the long-term credentials, which we don't talk about here. Then you got the original master secret where you derive new keys from. If that one is compromised, then you want to make sure that you could do something. So this is like a perfect 460 by redoing it if you key exchange. So you get a whole new fresh set of keys that generate session keys.
Yep.
I've opened the draft and the version 7 has 7 or 14 instances of long-term or long-lived.
Okay.
So you actually say
Let's
parties long-term
if you
keys.
could open a issue on GitHub,
Okay,
so
sure.
that we would again tighten up terminology a little bit more to clarify what do we mean by long-term key, that it's not certificate private key. Thank you.
In terms of DOS resistance, have you considered setting a floor in the number of bytes exchanged before these messages can repeat in quick succession?
We have actually, and it seems very much implementation specific, CPU specific, algorithm specific. We looked at how other protocols deal with that. There is no consistency whatsoever. So far, we decided to leave it as an exercise to the reader. Just as data points, again, in SSH and IPsec, you can do somewhat analogous process at any point in time. Protocols don't mandate you to do any kind of timer or transmit volumes, amount of bytes. WireGuard is more prescriptive there, but everything in WireGuard is prescriptive. So let's leave that outside of IETF.
All right. One last comment in terms of knowing that the session is no longer compromised after a memory dump. If the memory dump is quick enough and during an idle period in communications, the attacker could presumably also take over the communication channel and resume, right, on behalf of one of the other party, and then you don't really know.
Right. Again, this is this is not about recovering after a compromise. This is about reducing risk, reducing blast radius of a potential compromise. If you know that compromise has happened, then yeah, you probably need to switch things off and investigate instead of relying on extended key update to recover things for you.
But isn't that what post-compromise security is supposed to give you?
For some parts of the problem, yes, but not for others. I don't think post-compromise security guarantees that everything is now okay because we've done extended key update. Depends on what attacker have stolen and what they can then do with that information.
All right. So it sounds like just best effort rather than, you know, actual recovery, right? It's reducing the scope for such things, but you get no assurance.
Yes,
so that should be clear in the yeah.
Yeah, and this is something that we now discuss in security considerations, and it seems we could do a better job there.
Dennis Jackson, Mozilla. Yeah, I think thank you for updating the terminology and the graphics. I think they were great. In terms of the sort of extension mechanism that you're proposing with the IANA stuff, as I understand it, this extension is negotiated through TLS flags. And it also says that if there's an unrecognized message type, the client should abort and send an alert. So those wouldn't seem to play well with an IANA registry. So I think you would either need, some more expression in your negotiation, or maybe it probably makes more sense to not have a registry and just have some fixed message types. And if somebody wants to do something like this but not this, they just use a different extension point, and then you don't need the overhead of the registry.
I don't have a strong opinion there. Maybe
Just
I mean, registry doesn't really cost much. And then we've run into many situations over the years when lack of registry then backfires badly.
Well, I think if you want the registry, I think you need to be a way to negotiate, hey, I'm going to be sending some additional messages. Are you okay with that? Right, at a minimum. The other thing with the sort of threat model around PCS, I think it might be worth thinking about things like session resumption tickets and stuff and how they relate to this. Like if you do an extended key update, does that mean throwing away all past session tickets, for example?
Right, and that's actually what I do right now in the prototype that I've built. Perhaps worth codifying that. Oh, and one other, probably that doesn't belong to the draft text, but one other unpleasant discovery that I've made when building the prototype is quite often TLS stacks split socket after the negotiation into receive part and transmit part. And if you're just downloading and you're not transmitting anything, then you cannot complete extended key update because you do need to send data in the both directions. And if library doesn't have access to the both directions, then bad things happen. I guess some of those problems we faced in the past with renegotiation in TLS 1.2, but yeah, something that implementers need to consider.
Guidance. Yeah, thanks.
Okay, we exhausted the queue. Wow.
And I'll note that we've started the FAT formal analysis triage process for this document. We'll be collecting initial triage responses from the team and sending it and having a point person. Yeah.
Thank you.
Yes. Who's next? Next, I believe, is John. That's it.
Yeah. Thank you. So this is a presentation of the large record sizes for TLS with reduced overhead. Did not have time to submit the new version in time for the submission deadline, so this was submitted recently. Next slide. So there's quite few updates. There was some discussion at the last IETF and then also after last IETF on the mailing list and on GitHub. And I think we have addressed all the issues and submitted a new version. There's a clarification that basically everything works the same as in RFC 8449. There was a suggestion at last IETF that it should be a variable length field. Suggestion first that it should be done as in quick. Then on quick on GitHub there was a lot of discussion and the suggestion was to do it as in MLS and to name this new type var uint. So that has been done. It's similar to quick, but it has requires minimum size encoding. You cannot choose the size anymore. And then there's some clarification and corrections regarding to AAD limits. This is table is the same as in MLS, and that's basically it. We can take next slide. So I think it's quite stable at this time. No new issues. As before, there's an ongoing implementation, and I think we are starting to be close to working group last call, but very happy to take more comments or reviews.
Dennis, are you in the queue?
Okay.
All right, so I mean, it feels like we got a lot of feedback last time, and it got worked through in the repo. It is brand new, but that's why we have working group last call. So I'm going to propose that we do a working group last call, but as usual, we'll probably pause for implementations. So if that sounds like if that doesn't sound like the way forward, let me know what you think. All right, I'll go ahead and we'll get that working group last call issued as well. Okay, 1 second. Stop doing this. Do this. MLChem, selection.
Quick update on MLChem only registration. It's just registering MLChem 512, MLChem 768, and MLChem 1024. That's all it does. Here it is. Here are the IANA numbers. Here they are in the IANA table. This is what the document says. It says recommended N and nothing about MTI. You've seen this before. Hey, I deleted all these slides. Sorry. All right, so the updates as of 05, got some nice reviews, cleaned up language, aligned with ECDH MLChem on everything about what to do if any of the chems fail, which is literally just, let TLS do what it's going to do with it. Nothing explicit about like, there is a 1 in, 2 to the 300 chance that this will error and everything has gone, correctly, because there's nothing to do about that. So it's just whatever we're saying in the hybrid concrete Cypher Suites document, we're saying the same thing here, and we fixed up some refs. The only open issue is an open pull request, which is asking to change it from recommended equals N to recommended equals D for discouraged. This does not align what we're doing for similar hybrid MLChem Cypher Suites in ECDH MLChem. Would also require standards action, as we discussed before, and would end up grouping the brand new MLChem only Cypher Suites with null ciphers, RC4, DES, export ciphers, MD5, and so on in the IANA registry. This is the only open issue before we do maybe a working group last call. I just did a quick Google. This has been implemented and is merged into Boring SSL, OpenSSL, AWS S2N, Russell's, and probably others that I did not find. So this is already out there. Questions? I'll go back to the only open issue.
Not only is it in Boring, but it's also in Chrome behind a flag for 1024. So I don't see any reason to mark it as D.
Palo Alto speaking as individual. I was a little confused whether the pull request proposes to make D or to make N. Sorry.
The pull request proposes to change the current document, which is N, to D.
Okay, so then I think the last line of the slide pretty much summarizes why we should not do this, because these things are all broken and weak,
Right.
and this one is not broken by numbers of years of research so far.
Yeah.
Does anybody want to get up and speak to making it D? We're obviously going to take this to the working group last call, so if anybody wants to do it later, that's fine, but does anybody want to say now?
I'm willing to make it D. I think it makes some sense because we do have a clear alternative. It is implemented in OpenSSL. I'm the one who added it, but it's off by default, which is kind of aligned with D perhaps. Although if it then has, if standards action is a problem, then I'm not that strongly in favor of this.
Right. If we make the change from N to D, it would turn it from an informational to a standards thing, and yeah.
So yeah. So Victor, I didn't get the impression that you're like willing to fall on a sword on this either.
No, just inclined to let it happen and somewhat in favor of it.
Okay, thanks. Okay, so this to me sounds like we cancel this pull or you close this pull request and we get ready to issue a working group last call.
Yep.
Going once. Going twice. Okay. Stop the slide clicker. Who's next? Laura, I believe. Yep, Laura. I got the right deck up there. Excellent. By the time she gets up here, I'll click the clicker. Yes, there you go. You have the power.
Awesome. Hello. First time presenting as an adopted draft, so yay. Yeah, so since IETF 123, the draft was adopted. We moved our repo to the TLS working group GitHub, so please check it out if you haven't already. It's mostly been me talking to me. Yeah, and PRs are not up for all existing issues, that's a lie, but most of them. So goals for today are to sort of go over the open issues we've identified, get working group feedback, and identify any issues that we haven't even touched on yet. So these are the open issues we have right now. Most of them are honestly pretty small, and the PRs are like a couple line changes. So I'm not going to go through all these right now, just wanted to put them all on one list. I'm going to start with like the biggest, probably most controversial questions, and they're sort of two interrelated ones. The first one is sort of like, what are we willing to negotiate, and are we willing to support multi-round PAKEs? And then the second, sort of separate, but it'll also be like impacted by our decision on that, is what we want to do with the extensions. Do we want a single PAKE extension, or do we want to define multiple extensions for each of the PAKE algorithms? So yeah, this is the first part about which PAKEs we're willing to support and what we would have to do to support multi-round PAKEs. So the two basic requirements for a PAKE to fit into the TLS 1.3 handshake message flow are that they, one, need to have two messages to derive a shared secret. So one in the client hello, one in the server hello. And then the other requirement is that the key confirmation needs to be provided by the TLS finish message. So if they derive the same shared secret, then you know they both knew the password or the password verifier. Some PAKEs require more than two messages. This is going to make me really popular. Yeah, so we would need a new handshake message, which is obviously going to increase handshake time and handshake complexity. So to start, I'm just going to go over, like, this is our existing flow. SPAKE2 Plus and CPACE, which are the two we've like actually spec'd out, fit in this flow. So they start with a PAKE message in the client hello, PAKE message in the server hello. They both can derive a shared secret using the PAKE. That goes into the key schedule. And then the key confirmation is sufficiently provided by the TLS finished messages. Since if they both derive the same like shared secret, then you know that they both know the password or the password verifier. This also works with OQuake, which is a PQ symmetric PAKE. So to support a 3-message PAKE, we would have to basically find a way for the client to send back another PAKE message before a shared secret could be derived from the PAKE. So before the server could derive application encryption keys and send back encrypted extensions. So in the slide, I showed this as, and the motivating algorithm for this is CPACE OQuake, which is a hybrid PAKE, which requires that you run a classical PAKE and then a PQ PAKE. So they have to be run sequentially, which is what causes the extra round. So this could be a new handshake message. It could also potentially be a second client hello if we use HRR semantics. I have not thought through that approach. It would probably, either of these would be modifications to the handshake. And the next slide gets worse, but I'm going to show it. It's a 5-message PAKE. So this is CPACE OQuake Plus, which is a hybrid augmented PAKE. And it would require obviously 5 messages. The difference here being you still get a session like a shared secret after 3 messages, but that doesn't prove that you know the password. You have to do an explicit challenge response flow, and those would need to happen later in the handshake. So yeah, I don't need to go through the exact details. I feel like this is sort of a brief overview. Bigger question sort of being, are we willing to make modifications to the TLS handshake to support multi-round PAKEs? And what's the working group's response to that? I guess I'll start there.
Ecker gets in line. Hey, Ecker.
Timing. No. I mean, let's be clear. Like, there was like modest enthusiasm for this work. It was not like, let's rewrite the world enthusiasm for this work. So like, if we can cram it in, great. If we can't cram it in, then no.
All right.
David.
Wait.
David Benjamin. Whoop. Yeah, I would also add that for like the really complicated like end flow things, like there's sort of generally 2 ways that we could integrate something like this. We could either stick it in the handshake and sort of get the 1 round trip time thing, and also like, you know, have the nice like handshake then application data ordering thing, or we could do a TLS handshake, maybe anonymous or so, and then after the handshake, go run your funny auth thing with the channel binding. The benefit there is that we can do whatever ridiculous auth thing we want. The downside is now you sort of need to sandwich in between the auth layer and the application layer. So for something like the 2 message PAKEs where they sort of fit in nicely with a handshake, it sort of made sense to just go, we'll just stick it in there. But once we're at like 5 or so messages, like I think that's probably where the sort of channel binding approach is probably more natural. It's sort of unfortunate that we kind of have this like split and you kind of have to like decide which universe you live in, but that seems to be sort of the space we're in.
Especially if we do what Sophie Schmid, Google, especially if we do what David Benjamin suggested, it would be nice to also have short authentication strings mentioned somewhere instead of just PAKEs, because they're really nice and are underutilized. I don't think they fit into the TLS handshake without adding more messages either. But yeah, if you do them in the application layer, they would be really nice to actually have them written up somewhere.
Chris Wood, yeah, I'd say that again, the motivation for shoving this into TLS was basically so you could just like do TLS and then have the channel authenticated by the PAKE. It is super unfortunate that this complicated PAKE protocol has like 5 messages, and it would require like this pretty invasive change to the handshake. And so I appreciate the desire to punt that up to the application and do it at that layer. We wanted to avoid though this sort of problem that David was describing, which was like you potentially want to get your application to using something like HTTP, but you want to make sure that the authentication has been done correctly before HTTP runs. So you have like this kind of shim in between like TLS and the actual application protocol you want to run. But we were talking about it before the session, and I think like a reasonable compromise is something like you have like a kind of a custom application protocol that is specifically for like bootstrapping other long-term credentials, like a raw public key or PSK or whatever, using a PAKE or using a short authentication string or whatever. And then you like run this application protocol, and then like once you have your long-term secret, like jump over to a new connection using HTTP. And that seems like it would make sense, especially because like the use cases where this is relevant or that motivated this work was not like latency sensitive. You know, it's not like eyeballs won't be sad if they happen to do this. So I think that would work. That would be like not work that's done in HTTP, not work that's done in TLS, but like some new application protocol that we could probably like, I don't know, try to scope out or whatever as like a BOF or something next time, if that's the approach we want to go down. But especially if it accommodates things like short authentication strings, in addition to PAKEs of any rounds. Like you could even like take if you had this application protocol, you could take something like SPAKE2+ and do it this way. And then you wouldn't be in this unfortunate situation where someone would have to choose between the TLS approach or the non-TLS approach. So maybe that's the route we go down. But yeah, I just want to say like that was the motivation for this altogether. Shoving in TLS was like, so you don't have to do this like custom complicated application dance, but maybe we'll end up back there anyways. So, well.
Hey. Hello, it's Mohibul Mahmood. I'm relatively a new participant. So my question is on on mixed deployment case, so how this draft plan will prevent applications from unintentionally degrading from the certificate-based authentication to PAKE-only mode. Yeah. So in case of it is a mixed deployments. Yeah.
So you're saying like in deployments where the server is willing to negotiate either with a certificate or with a PAKE?
Yeah, if it is how it is prevent from downgrading to the, yeah.
So right now in the draft, as we specified, like if a client sends a PAKE extension and it sends signature algorithms, it assumes you're doing a PAKE and a certificate. You would have to do both.
Okay, thank you.
Okay, so I will move on to the next one. Feel like that was a very clear, we're not going to do this. Okay, so this one again was or was the queue empty? Sorry, it was not. Yeah.
Hi, Jonathan Hood. I was just wondering if another way of thinking about or approaching this, which is very inspired by what Chris said, would be to have a way of injecting a channel binding or key material into the TLS handshake. So you do the first 2 steps of your PAKE or 3 steps of your PAKE pre-TLS, either in another TLS connection or whatever, and then inject the state into your TLS key derivation. And that gets you, that sort of avoids the issue of having to extend the TLS handshake.
So you're saying like run the PAKE first and then use its
and then
output
bind it
somehow?
together.
Yeah, that could potentially work. I think one thing I need to talk more offline to David Benjamin and Chris is want to make sure we have a place where we can standardize this. A lot of this has to do with like interoperability, and I feel like it's a weird layer between TLS and HTTP is sort of a weird land to be in. But yeah, I feel like it's probably the right approach than trying to hack it onto the handshake. Okay, so the second one, again, it was sort of related to the first one, but it doesn't really matter. It's a little bit less important if we're not doing the multi-round PAKEs, but it's essentially right now we've declared one extension called PAKE, and it could have any PAKE algorithms defined in it using PAKE schemes. And it's whether we basically want to change that approach. So the other alternative is instead defining multiple extensions, like one per algorithm. So that would look something like this. So defining more extensions instead of having, so each extension could define its own semantics or have its own like PAKE algorithm parameters set to it. The reason this was better for multi-round PAKEs was if you wanted to mess with the message, like which messages each extension could be on, but that's not going to be an issue anymore. So it's more just a matter of preference. Do we like this approach or do we like the current approach, which looks like this? So it's one extension with multiple like PAKE scheme, like code points identifying each PAKE, and it's associated with parameters. And does anyone have, opinions on that? The biggest advantage, or like the only difference I really see between the two is with this one, we could potentially, like, we currently only send one client identity and one server identity. We have an open issue on whether that's the best approach and whether we want to actually support sending multiple, but we couldn't do that at all with this approach. So should we be sending a client identity and server identity for every like PAKE algorithm? Should we just be sending one? And then do we care about the extension format is sort of the question. We can just leave it as is, or yeah.
I think I like the idea of just having one extension, drawing the kind of the simplest, most constrained box that we can for this kind of thing. Specifically for the reason I'm nervous about supporting multiple rounds. So yeah.
Yeah, I think that's fair. Sort of say this one, and then this is just the 1 round PAKE that I had on that first slide.
If you have 2 extensions, doesn't a lot of you say things? Doesn't a lot of the servers say things that are incoherent? Like I support 2 different PAKEs simultaneously.
The server would say that?
I mean, the server could, right? If
you have 2 like what does the client do if the server sends back both?
I haven't gotten that. I haven't gotten there yet, but yes, that's where I'm going, right? I mean, it seems to me like this that this allows you to at the PDU layer say it's impermissible to choose more than one PAKE, whereas I mean the way extension processors and TLS typically work, right? Is they're kind of independent, and so you have to store like at least an SS one is, and so you got like store like he like chose he like chose this PAKE and now chose this PAKE and like yeah you can't do that, right? So I think I prefer not to have a design that allowed you to say incoherent things, unless there's a strong argument for the design that other design.
Cool. Yeah, I don't have a strong preference either way. Just wanted to talk through both options. What about I guess since we're already on this slide, does anyone have opinions on whether we want, like right now we have client identity, server identity, and then a list of like any of the offered PAKE shares. So like if you're offering SPAKE2 Plus and CPACE, there'd be 2 in that list. Would we prefer to have a client identity, server identity per share?
Oh, what use cases would we have for multiple identities for either side?
I'm not totally sure, which is why I originally wrote it this way. But I think Edgar brought up in the past that like I'd also mentioned like, oh, there was a client enumeration risk with that, but there's not as long as we specify that like the server needs to pick like which PAKE algorithm it wants first versus inspecting like which identity do I recognize?
It's a little over my head.
There's a GitHub issue number 6 where I pasted what you wrote.
Would one potential use case for sending multiple server identities be, I, as a server, have decided I want to migrate from one PAKE to another, and therefore the second PAKE would have a different identity?
Maybe I would need to think about that, but that could be a good argument for it, potentially.
Okay, thank you.
I'm not really sure. I mean, we kind of depend if there was some way you were deriving these identities, like how do you get the identity? If it's somehow tied to the algorithm or something, then you might kind of be stuck with different identities for each one, but it doesn't seem like you would do it that way, but I would have to understand a little bit better how you would, if it's just something you choose, then it seems like it could be the same. But
I now remember my point. So for the client, it typically doesn't matter. The client knows the password. But supposing the server has a different disjoint verifier database for different PAKEs, then you can get into kind of an odd situation, right? Whereas, and the client may or may not have that information. So, I mean, I don't think it's a huge issue, but that was what I had in mind. I'm not gonna lie down the road either way.
Okay, I guess we can continue to think about if there's any use cases where this would be helpful. We're not going to go over that one. Okay. Okay, a lot of these are sort of small, but I just figured since we're here, we have the time, and we went really fast today. I'll just keep going.
Yeah, keep going. You got time.
Okay. So this one's maybe somewhat related. It also has to do with client enumeration. It's a very, yeah, these are sort of small, but basically we said a client can send both a PSK extension and a PAKE extension, and the server can pick which one it wants to do. You can't combine them. And basically, I just wanted to add text that says like the server should choose between the PSK PAKE extensions based on its preference for which like authentication mechanism, not based on like whether it knows the client identity. Otherwise, an attacker could potentially like do a client enumeration attack. So that's literally all that changes. Cool. This one's even smaller. I want to add a TLS prefix to the context string. And those are all the open issues. So yeah, I guess we still have time. So if anyone else has looked at the draft and has thoughts on like other questions we should be answering or looking at, I'd love to hear about that.
Just going back to the multi-round PAKE, what would I gain by having a multi-round PAKE? Is there some multi-round PAKE that's like, cures, some rare disease
Cancer.
or something? Or is it like, is there a reason, is there like a concrete reason why I would really want this other than like, well, my PAKE doesn't, has more rounds or.
Chris, did you want to answer? I saw you got up. Okay.
Yeah, so our PQ PAKE is the reason why it has multiple rounds, and it's not because more rounds is better, despite contrary or popular belief. It's because we want a hybrid security property wherein you need to break both of the classical and the post-quantum PAKEs in order to actually recover the password. And to do that, you have to run the two PAKEs in sequence as opposed to running them in parallel. And like there are technical reasons for that, but that's basically what it boils down to. If we could do it with fewer rounds and fewer messages, we would love to, but that's true. But yeah, that's the reason.
Dennis Mazzilla. In terms of any other stuff, you've got sort of the guidance, the framing of the document. It looks great, but I would maybe try and give a little bit of guidance to somebody reading this on when they might want to use it. And I think it's very much like when you have no alternative. Like if all you've got is a low entropy secret, great, here's a PAKE. But if you've got anything else, use that instead. And I think that sort of framing might help people know when they need to use this kind of thing.
Jonathan?
Just a question on the last point. Was the idea of the TLS / thing that you want to distinguish it from quick, or?
Yeah, I guess I was just thinking that right now we basically said the context could be empty or could be provided by the application, and this would just maybe prevent against like cross-protocol attacks. I didn't have like a completely specific one in mind, but figured we should prefix for TLS.
But if you were using SPAKE 2+ in quick, what would you put as the string?
Oh, sorry. I guess it would still be TLS.
Okay.
So a general question on the draft, you mentioned about the open issue in one of the sections, and that says basically this requires formal analysis to confirm section 8.4. I was wondering if the formal analysis is already ongoing. Have you already started, or are you looking for someone, or what is the current status?
We've done some work so.
It just died. I'm sorry. I'm gonna just try to use that one. That's weird.
Just hold on to this. Sorry. We've done some. I don't think it's up to date with the current draft version.
So
and
something
if
is
you are interested in
ongoing.
doing more, that would be great.
So something is ongoing, so you don't need any specific help on the formal analysis. That's what I wanted to ask. Like you guys are already doing formal analysis, right? Is this correct, or? No? Okay.
I'm not sure. Sorry.
Chris Wood, yeah, analysis is underway, but of course, like more people can contribute to it. That's I'm not going to say no to help, but it's a working group document now, and if people are interested in doing that analysis and helping with it, fantastic.
I heard a suggestion that this should be sort of not recommended when other options are available, like certificates. My view is that a client that has a reasonable, entropy peak actually has much better assurance that it's talking to the right server than when some third party did some unknown test to give the server a certificate. So we should not discourage this too strongly, because it can actually be the most secure option available in some cases.
I don't think it's usually the most secure option available. Sorry. I don't think it's usually the most secure option available. Pegs are very specifically only secure if you do some rate limiting on the amount of tries that you get. And while you can do that in a lot of situations, it's not something that you can just point at any problem and assume that it works. So I don't think it's it's a nice thing to have, and I really like that it exists, but it is a very special case primitive. I don't think we should encourage its use without further analysis of the case around it.
Right. I'm not saying encourage, I'm saying don't discourage too strongly. If the client knows it has a very strong secret, then it can be the more secure option.
Just speaking as myself, the hybrid PAKE you mentioned, Chris, uses Oquake, which uses one round that would fit in the existing key exchange. And it's pure post-quantum. Would you be interested in registering that or writing that up?
He left. Chris has disappeared. Yeah, Chris left.
Any author. Yeah. Try to fix the mic. I said yes, we'd be willing to register it.
Okay. As for using PAKE as a generic security mechanism, I would like to point out that one problem with a PAKE is the necessity of exchanging, at least using symmetric PAKE, is the necessity of exchanging the same password, high entropy or not, to both sides. That is a fundamental problem, and it rather is discouraging. It makes it difficult.
Yeah, I agree. It'd be hard to use PAKEs in the places where you'd normally use certificates. I would argue I see some use cases where external PSKs would potentially be used. Like having a higher entropy going into a PAKE is okay. All right.
Should we take the other mic? We put it best, but we use, I like the mix. Okay.
Yeah, Rick, do you want to just do it from there?
How about I take this up there? Yeah. You're not going to have any questions. All right.
I am the expert. I will tell you.
That's right. Yeah. No, I'm working. Oh, okay. Is Sabrina here? Where is she? Sabrina is the IANA contact we use most often, so thank her. Yeah, okay. There were many updates to the registry, most of them kind of editorial, things like TLS 1.2 frozen, added another column, 8446 BIS, 8447 BIS, a lot of references to all of the documents changed. The more interesting ones are the ones here at the bottom. There was a new return, I forget what it said, return receipt control a new registry added for that for the DTLS. You can specify alternate ways to indicate that the return path still works. SSL key log file, new labels. So if you want to, for debugging, record all of your private keys, you could now just register them. Not saying you should, but if you wanted to. ECH config, that comes from Stephen and me and some other document. So there are extensions for adding in the ECH data to the HTTPS binding. I thought this was a really cool trivia fact. When I asked Sabrina what has changed since the last year, she just included a transcript that had, the Git log with the before and after. So, okay. Some simple additions. There's a new alert type. General error came from 8446 BIS. There are 3 new signature schemes, as we heard. MLS, 44, 65, 87. There's 1 new supported group, which adds P384 to the hybrid key exchange. There are 4 new cipher suites that we just added last week. These ones are interesting because they are from the NIST. I forget the actual term, but it was for, pardon me? Oh, it was from the NIST lightweight, thank you, I couldn't think of the word, lightweight cryptography thing. So they started to write a draft. They started to write a draft. Paul had pointed out, well, if your content of your draft just says points to the NIST spec, why don't we just register based on the NIST spec? So that's the first time I think we've ever done that, having something, we have registry entries based purely on an external specification. The only thing that caused it to happen was they sent mail to IANA saying, please register these things, and here's the reference. And so we approved it. Yeah, we can do that. It's even lighter weight now. Go ahead, Victor.
Since is SEC P384 MLChem 1024 new? It was around back in February when I implemented it.
It only just showed up in the registry.
It was in the registry. That's where I got the code point, I thought.
Okay, well, okay. So, well, then
maybe it was only in a draft. Maybe I'm misremembering where I got it.
Yeah, either you misremembering or Git got something wrong. Okay, SLH. So this came from an unadopted draft. As we all know, there was discussion. There was a major concern that the concept was not fit for general use in TLS. There are 3 security levels. You can do small or fast and 2 digests. You multiply those out because you're doing all combinations, and we got 12 ciphers. So we pushed back a little bit. Yov started it, saying, it's an unadopted draft and nobody else has done more than 2 or 3. You sure you need all 12? And I added, could you consider a private use until you figure out which ones are actually going to be used? But they were insistent. And per the designated expert registry instructions, we have no choice. So they're going to be registered, sometime whenever we get around to doing the mail after this week. And that's it. Anybody?
Victor, are you still in the queue?
Yeah, Victor, you still in the queue or not off the queue? There we go.
Excellent. Okay, cool. That wraps up our session. We have another session on Wednesday. Just to remind people, we're going to have like 3 working group last calls flying out. I'll probably give it an extra week just because this week people might not be reading them, but we want to get them started. Get ready for it. If a huge blow up happens on any one of them, don't forget there's 2 others going on. Thank you very much. So if you guys are cool with that, I'm going to issue this last calls tonight. At first I was like, oh, let's just pile
I mean, I would run it till sometime.
So we gotta keep option A, slide across, right? That one. So you'll see a message about that tonight. I'll do the work with that. Jumbo wellness engaged. Good. Oh, I remember. People who wrote the draft. Yeah, you have 4 pieces. You do one, I'll do the 3. But the fun part is it's an automated data track. It's okay.
Just to say hello.
I'm dry running slides and I'm not.
So you said,
Are you going to send me some slides before? No, if you want to go through it. Felix just tell me he wants to do Windows security software.